Hello guys, can everybody hear me okay and see me okay? Excellent, that's looking good. Well, thank you guys for joining me today. My name is Neil Johnston from Thorlux Lighting, Australasia. I'm going to be talking to you about lighting control systems. Quick overview on what we're going to be looking at is energy usage. What is a lighting control system? General types of lighting controls, controls terms, comparisons of control systems, a quick case study, and a conclusion. Modern businesses nowadays, the operating expenses are probably 30% at least on utility costs, and we know that 50% of that cost is going to be attributable to lighting with no controls. I think we're all very aware of the fact that energy prices are increasing. Us guys in Queensland have just been hit with a 22% increase this year for our electricity. As we can see from the graph, 42% increase in the last 4 years, and they're forecasting another 50% increase over the next 3 years. This obviously puts a lot of pressure on businesses and individuals to reduce the energy consumption and improve their energy efficiency. So how do we go about reducing energy? For us, we think it's simply lighting control systems. We can reduce the electricity consumption, achieve real and significant savings, and maintain lighting levels. So what is a control system? Well, simply, a control system is a device or devices that allow us to control electric lighting. So anything from a simple light switch through to PIRs, daylight harvesting cells, complex scene setting devices. The reason we use lighting controls is it gives us the chance to occupancy switch, to make use of the available daylight, maintain lighting levels, set scenes, aesthetic reasons, so we can now use it for colour change LEDs on building facades, etc., and also security lighting for both interior and exterior. The benefits of lighting controls: obviously it gives us advanced energy management, the ability to power on and off individual or groups of luminaires. Nowadays we're also including ceiling fans, blinds, air conditioning and other devices along with that. So general types of lighting control. First thing we're going to look at is occupancy sensors, and they basically detect the presence or absence of people using a combination of methods. The most popular method is passive infrared, or commonly known as PIR. The PIR occupancy sensors basically sense the difference in heat emitted by humans in motion from that of the background space, as shown in the slide. The way that a PIR works is the sensor's lens views its coverage areas as a series of fan shapes, and what we'll find is movement between the zones gives detection. Movement between the zones is going to be a little more difficult. We'll probably have 12-metre diameter detection for large movements, and that goes down to a 4-metre diameter for small movements such as hand movements, so in offices and schools, in classrooms. We have to be a little bit careful with PIRs. They are temperature sensitive, tend to work best between 15 and 30 degrees. If it's above 30 degrees, the PIR becomes less sensitive. If it's below 15 degrees, the PIR becomes more sensitive. The way Thorlux look at PIR detection is we have what we call a two-wire motion line between any luminaires and any PIRs, which allows us to actually switch groups of luminaires rather than individual luminaires. The reason that we do this is originally, back in the olden days when we used to supply individual PIRs or individual luminaires, we found that in big offices and classrooms, etc., people didn't like being plunged into darkness. So we had to come up with a way of actually switching more than one fitting. So what we do now is we connect the luminaires with our motion line, and that allows us to switch groups of luminaires rather than individual luminaires. Potential savings, as we're talking about energy saving and cost saving, there was an American study done that looked at 158 rooms, including offices, classrooms, conference rooms, etc., and published the potential energy savings for these spaces just using PIR control. And as we can see from the list, you're probably looking at sort of 20 to 25% saving for a general area. The next item is daylight harvesting. Daylight harvesting we use to maximise energy efficiency alongside PIRs. So basically we use natural daylight coming in through windows and roof lights, which will then allow us to dim the artificial lighting and still maintain a set lighting level. By using daylight harvesting, we can actually get savings of 40% plus. So obviously we can see if we put that with the daylight and PIR savings, we're probably saving 60 to 70%. This also helps to meet the green buildings ratings, so Green Star and neighbours, etc., etc. What we're talking about with wasted energy is the bottom line, the maintained illuminance. That would be if we were lighting an office, we were lighting that to 350 lux, and we wanted to maintain that 350 lux. What happens is during the day, from dawn to dusk, we can see that there's daylight coming in through the windows. So all of that blue area is actually wasted energy, because we can take the lighting from the sun and use that to dim down the luminaires and keep at the maintained illuminance level. The way this works is daylight harvesting. We can use the light from windows or roof lights. As I mentioned, the way Thorlux look at doing this is we actually incorporate a daylight cell and a PIR controller into every luminaire. We think this is the best way of controlling lighting. If we look at the top slide, we can see that during the working day, with the sun coming in through the window, the luminaires closest to the window will probably be off or at an extremely low level. The luminaires in the centre of the room are probably going to be on at 40%, and the luminaires closest to the wall, so furthest away from the window, receiving the least daylight, will be running at approximately 60%. We also have maintained illuminance savings. So even if there's no daylight coming in through the windows or the roof lights, nowadays when we design a lighting scheme, we have to take into account lamp degradation, luminaires getting dirty, interior surfaces getting dirty. So we actually over design the scheme to start with. So we're probably looking at 20 to 25% overlit from day one. Obviously, by using the daylight sensors, we can go in and program the lighting to maintain the 350 or 500 lux, thereby saving a further 20%. Now, how does this work in real life? Well, we've looked at warehouses, lots of luminaires using lots of energy. Normally, all the fittings would be on at 100% output without controls. Obviously, some warehouses are now running 24 hours a day, 7 days a week, so a lot of wasted energy and a lot of wasted money. Basic solution is we would use a PIR, presence detection. As we've mentioned before, with the Thorlock system, we would connect all of the luminaires together. If each luminaire works on its own PIR, we're back to the same old problem of people travelling into dark areas. So again, if we're looking at a warehouse racking aisle, you can see the guy driving down the racking aisle and he's driving into darkness until the third fitting picks him up and switches on. The Thorlock way is PIR plus the motion line. This basically means that as the truck or the person turns into that racking aisle, the first luminaire will detect, and that will then send a signal to all of the other luminaires on that group and bring them all on. This obviously makes for happy employees. With the smart system, we also incorporate daylight dimming. As we can see from this illustration, with the roof lights and the sun being high up in the sky, giving us plenty of lighting in the racking aisles. So the luminaires are actually dimmed down to between 30 and 40%. And even on a cloudy day, we're still looking at getting between 50 and 60% savings. So the smart solution saves energy, reduces CO2, gives us a short payback, and hopefully is very user friendly. Some of the terms that we're using in controls, we've got 1 to 10 volt, so this uses a DC signal connected to each luminaire and dims by varying the voltage from 1 volt to 10 volts. We've also got DSI, which is Digital Serial Interface, which is the precursor to DALI dimming systems and uses a digital dimming system to DSI compliant devices. DALI stands for Digital Addressable Lighting Interface, so also uses a digital dimming signal but to addressable compliant devices. And the last one is wireless, so this is quite a new technology. Everybody is trying to work on wireless controls at the moment, so we think that may be the next big thing. The pros and cons of these systems. 1 to 10 volt. Cost is a pro. It's the earliest system. The cost is the cheapest. It's very easy to install. It's just a two-way cable to connect between luminaires and controls. The downside of 1 to 10 is it will only do group control. Obviously, because it uses 1 to 10 volts, it can suffer from voltage drop over long distances. It can suffer AC interference. It's polarity sensitive, so the two core connection cable between the devices has to be connected the correct way round or your system won't work. The other downside is it needs a mains switch to turn off the luminaires, because as it's 1 to 10 volt, the 1 volt will only dim the fittings to 10%, so you must have a mains switch to turn the luminaires off. DSI, this was the next step on from 1 to 10 volt. We know that it's a reliable digital system. Again, very easy to install, just the two-way cable. This one is not polarity sensitive because it's a digital system, so the two-core cable can be connected either way round, and we can also switch it using the control wire, so no mains switching is required. The downside of DSI at the moment, only one manufacturer, that is Tridonic. We don't see that as being a huge problem. They are a big international controls company, so you pays your money and you takes your choice. Darley, this is what everybody seems to be talking about. The plus is it's individually addressable luminaires, digitally reconfigurable, so we can actually change the setup of luminaires by simply using a laptop or a PC. Again, it's not polarity sensitive because it's digital, can be switched using the control wire again. It's very easy to do scene setting with Darley because again we can address individual fittings. The other plus for Darley is it actually gives us feedback from the luminaires. So again, if we're connected to a PC or a tablet or an iPhone, it can actually tell us how long the luminaires have been on, how long the lamps have been running for, at what output the lamps have been running for. Is there a problem? Are any of the lamps gone? Are the ballasts gone? Also, it's compatible between manufacturers, so there are a number of people manufacturing Darley controls. The downside for Darley is it can be complex to commission, again because we've said everything is individually addressable. So as you can imagine, if you're doing an office building with 1,000 luminaires and each one has got its own individual address, that can become quite complex. Also, if the ballast fails, the whole system has to be reconfigured. This is because the information is stored locally at the ballast. So if that ballast were to fail, then with the system has to be rebooted. We have to supply a new Darley ballast and the whole system has to be reconfigured. And lastly, wireless. The big thing is obviously no cabling between controls, but on the downside at the moment, we still obviously need mains wiring. So if it's a new installation that we're putting together, if we've got to get the mains between the fittings, is that going to be a problem getting the controls cables between the fitting? Limited distance communication. We think at the moment the maximum distance is about 3 meters, so possibly okay for offices, but certainly it's not going to work for external, and it's not going to work for industrial projects at the moment. The communication signal is an infrared signal, so it cannot see through objects. So if somebody moves into a big office space and starts putting up partitions and starts putting up separate offices, then the luminaires will not be able to communicate with each other. Possible interference problems, again with the infrared, as lots of items we use every day has infrared controls. So if you're doing scene setting or you're doing presentations, a lot of the handheld remotes will use infrared. That may interfere with your lighting system. Also won't be suitable for all luminaire types due again to the infrared interference. We know that lamps give out large amounts of infrared, which means that the ballasts and the lamps have to be shielded from the controls in case there's any infrared interference. Looking at a quick case study, we can do lots of payback calculations, etc, etc, but I don't think anything can beat actually looking at a case study. It just so happens that a few years ago we actually renovated our Thorlux factory back in the UK. it's got extensive roof lights, and basically all we did is we kept the same luminaires that were there before, 2 by 58 watt T8 reflector fittings, and simply refurbished them with digital ballasts, daylight linking cell and PIRs. As we can now see from the average power consumption, during the winter months, so January, February time, the luminaires are still working quite hard to give us the maintained lighting levels that we need, but as we work through to April, May, June, so the summer months where we get lots of sunshine, we're looking at probably 70 to 80% savings. And here's a little table showing those savings. Originally we supplied, or we used, 2 by 65 watt old T12 switch start luminaires. We upgraded those to T8 high frequency luminaires, and as you can see from the bottom figure, that saved us around 30%. And then by upgrading simply to daylight linking and PIR control, we're now saving over 65% on our lighting energy bills. Now, in conclusion, we think it's our opinion that building designers, architects, consultants, engineers, end users really should consider offering at least some form of controllability on all projects now, even if it is simply PIR controls in certain areas. But for us, we think controls should form part of an overall lighting strategy. So along with the lighting controls, we should be using high efficiency lighting ballasts, high efficiency luminaires, and also, where we can, pre-programmed lighting schedules. So we now know that lighting controls can contribute to saving energy. If designed correctly, a system should give a high degree of user satisfaction, allows lights to be provided in the right amount where and when it is needed, and gives us the ability to control individual light fittings or groups of light fittings from a single user interface device. I think we now all appreciate that daylight improves the internal environment and has a positive impact on productivity and health. So if we can use it for that and at the same time save energy, we think that that's a positive way to go. Now, as we've discussed, there's multiple ways to control lighting, everything from a simple switch to handheld remotes to iPads, iPhones, scene setting, right the way through to very complex colour change, dimming LED systems. So for us, I think what we would say is we can actually make it as simple or as complex as the client requires. I think we would just say, speak to the clients, see exactly what they want the system to do, and realistically work back from there, rather than trying to get in a system that possibly is not going to be what the client wants. And that's all, folks. Thank you very much for your time. Our website is listed on there. If you have any questions, then please feel free to email through or go onto our website and have a look. Also, the Voltimum guy has asked if you would all take part in a quick survey on this webinar, just to get some feedback and also your thoughts for any upcoming